Hello, future engineers. This video will discuss about rectangular representation of vectors of forces and resultant of concurrent non-coplanar forces in the last part. So you have to like 3D force systems and the vector approach to forces because it is very effective and powerful tool in dealing with forces. If you are accustomed to 2D, then you're behind because the real forces or the real force systems should be the 3D force systems. Now I already discussed the principles on this in statics for beginners too, and I greatly discussed that in that video. I just consider this very shortly here as your guide in our 20 levels of examples. So that's it. So let's have rectangular representation of vectors. Let's have a review. If you want the detailed explanations of this, so proceed to statics for beginners too. So F is F times unit vector of F. So it is magnitude of F, quantity cosine theta xi plus cosine theta yj plus cosine theta zk, where F cosine theta x is the x component of the force. So you can also write this as Fxi plus Fyj plus Fzk. Fx, Fy, Fz are components of F along x, y, and z respectively. And I, j, k are the unit vectors of F along x, y, and z. Where cosine theta x, cosine theta y, and cosine theta z are called direction cosines, and the magnitude of the unit vectors also, these direction cosines, which are also unit vectors of F along x, y, and z axis respectively, while theta x, theta y, and theta z are called direction angles. The angle that F makes with the positive x-axis, positive y-axis, and positive z-axis respectively. So cosine theta x is simply fx over f. It is cosine theta y is fy over f, and cosine theta z is fz over f. So that this is also explained in statics for beginners too. If the vector or force is directed from point A to point B, then its unit vector is denoted by lambda AB, and it is equal to xb minus xa I. It is also the ratio of f over magnitude of f plus yb minus yaj plus z sub b minus g sub a k all over distance ab, where xb is the terminal coordinate of the force or vector, the tip, while xa is the x coordinate of the tail. So terminal minus tail coordinate. And distance AB is simply square root of quantity xb minus xa square plus quantity yb minus ya square plus g sub b minus g sub a square. We can also denote this by delta x, delta y, delta z. So distance AB is square root of delta x square plus delta y square plus delta z square, where delta x, delta y, delta z may be thought of as the dimensions of a box enclosing the tip and tail of the vector or force. Then cosine theta x is simply xb minus xa over distance ab. Cosine theta y is delta y or yb minus ya over distance ab. And cosine theta z is z sub b minus g sub a over distance ab. So thus, fx over f is xb minus xa over distance ab. Fy over f is equal to yb minus ya over f. They are same as cosine theta x, same This one is cosine theta y, and this one is cosine theta z. Fz over f is g sub b minus g sub a over distance ab. Or fx over the f equals delta x over distance ab. Fy over y is delta y over distance ab. Fz over f equals delta z over distance ab. So rearranging fx over delta x so that you can easily recall it, x component of force over x component of distance equals y component of force over y component of distance, z component of force over z component of distance, force over distance of force, where the force is directed to, is constant. So that ratio is constant, and we call that force multiplier. So that fx is simply delta x times force multiplier. Fy is delta y times force multiplier. Fz is delta z times force multiplier. And of course, f is distance AB times force multiplier. So cosine theta x is delta x over distance AB. Cosine theta y is delta y over distance AB. Cosine theta z is delta z over distance AB. And remember that the sum of the squares of direction cosines, cosine squared theta x plus cosine squared theta y plus cosine squared theta z, is unity. That is fx over f squared plus fy over f squared plus fz over f squared is f over f quantity square, or 1. So fx delta x force multiplier, fy delta y force multiplier, fz delta z times force multiplier. Then I'll discuss very briefly that product, although this topic is discussed also in beginners statics for beginners 1, I think. So vector A dot vector B is magnitude of A, magnitude of B cosine theta. Application of this is you can find the angle between the two vectors, or you can compute the component of one vector in the direction of the other. So for example, A cosine theta. A cosine theta is the component of vector A in the direction of B, while B cosine theta is the component of vector B in the direction of A. So that's it. So FAB, for example, is F dot unit vector of AB. If we expand this is magnitude of F, magnitude of unit vector AB, which is 1, times cosine theta. So this results to F cosine theta. That's why F cosine theta is the component of the force F in the direction of the unit vector AB, and that is the component of force in the direction of AB. So it is simply FAB. So we need this in some of the problems, especially in the upper part, moderate or challenging ones later. Resultant of non-concurrent, non-coplanar for systems. It's easy to compute the resultant if you express all forces in vector form, because the resultant in vector form also is simply the sum of the forces in vector form. So that is R is F1 in vector form plus F2 plus F3 plus dot dot dot. So we just add corresponding X, Y, and Z components, ijk, and that would be the resultant in the form also of ijk. So it's easy. Level 1 problem, express the 4,500 Newton force F in terms of the unit vectors I, J, and K. Determine the projection of F onto the y-axis. The projection of F onto the y-axis is the component of F onto the y-axis. So this is just Fy. This is the given figure. The force is directed from point A to point B. So the force in vector form is F, magnitude of F for 4,500 times delta X, or XB minus XAI plus YB minus YA j plus g sub b minus g sub a k all over distance AB. So this is the vector form. F over distance AB times xb minus xai plus yb minus yaj plus g sub b minus g sub a k, where xb minus xa is 60 minus negative 48 in centimeters. So that would be 108 centimeters. YB minus YA is 30 minus negative 25. So it is equal to 55 centimeters. And G sub B minus G sub A is 40 minus 20 equals 20 centimeters. Distance AB therefore is square root of 108 square plus 55 square plus 20 square. So distance AB is equal to 122.84 centimeters. So substitute here, where F, magnitude of F is 45. So 4,500 over 122.84 times quantity 108I plus 55J plus 20K. So using your calculator there, F is 3956I to 4 significant figures plus 2015J plus 732.7K newtons. And the projection of F onto the y-axis is simply Fy. This is the y component of F, so 2015 newtons. So that's for level 1. Level 2 problem, obtain the rectangular representation of the force P given that its magnitude is 150 newtons. So here is the given figure. If I'm going to solve this problem, it will only fit in this part, but I need to discuss this in a more detailed way because this is the first example so that you can follow, especially those who are not accustomed to 3D problems. So first, this is a right triangle. We have to solve this side first. This is vertical parallel to the z-axis, so automatic this is PZ rather. And the angle that this force makes with the z-axis is 40 degrees, 90 minus 50, because this is a vertical angle 50 degrees. The angle between vertical and the horizontal is 90, so this is 40 degrees. In other words, theta z is 40 degrees, and the z component of the force is P cosine of theta z. So let's compute for this component first, hypotenuse of this imaginary right triangle. Call that pxy because it is on the xy plane. Then after pxy, this is px opposite to 30, so it's negative because this is the positive x direction, while py is positive because that is in this direction, adjacent of 30. So this is also pz, which is p 150 sine 50 degrees or 150 cosine of 40, because this angle is 40 degrees. So theta z is 40 degrees. So pxy is equal to 150 hypotenuse cosine of 50 degrees, this value here. So if you solve for px, which is this component opposite of 30 degrees, so let's draw the top view so that you can understand. This is 150 cosine 50 pxy, and this is px, this is py, and that is px. So px is in the opposite direction of opposite to x, so that's why it is negative. And px is this opposite to 30, so it is negative. Negative 150 cosine 50 times sine of 30. So hypotenuse sine of 30, but it is negative, that value there. So px is negative 48.21 newtons. Py is hypotenuse, positive in the positive y direction, 150 cosine 50 times cosine of 30. So 150 cosine 50 degrees times cosine of 30 degrees. So P sub y is equal to 83.5 newtons. Lastly, PZ is either 150 cosine 40 or 150 sine 50 in this right triangle. So if you're still confused, it's because your trigonometry is not fit to this course. Maybe you're not yet good in trigonometry. How come? This is already statics. 114.9. So therefore, the force P in vector form in ijk in vector form is P sub x, which is negative 48.21i, plus Py 83.5j, then Pz 114.9k newtons. Level 3 problem. The slider travels along the guide rod AB with a velocity 6 meters per second. Determine the rectangular representations of letter A, the unit vector directed from A toward B, and the velocity vector V. So this is the velocity directed from A to B. First, for the unit vector directed from A to B, lambda of AB, which is xb minus xai over distance AB, then yb minus yaj plus g sub b minus g sub a k all over distance AB. So xb minus xa, this is 0 because xb is 0 because it is on the yz plane, while xa is positive 8. So 0 minus 8. I hope that in the figure you can analyze the coordinates. Then yb is 16, ya is negative 10, so 16 minus negative 10, 26. Yb minus ya is 16 minus negative 10, so it is 26. Then g sub b minus g sub a is, g sub b is 12 above the xy plane. A is 0, so 12 minus 0. So it is 12. Then distance AB is simply square root of 8 square plus 26 square plus 12 square. You don't need to put the negative sign, but this is the guide for ijk later. So distance AB is equal to 2 square root of 221 meters. So we can now have the unit vector. Lambda of AB is negative 8i plus 26j plus 12k all over distance 2 square root of 221. Then expressing in decimal form, so that's the unit vector AB. Negative 8 over 2 square root of 221 in decimal, 26 over 2 square root of 221, 12 over 2 square root of 221. Then for the vector V, it is just magnitude of velocity, which is 6 meters per second, times this unit vector. So in vector form, V is 6 times that unit vector there, and then distribute. Actually, you may leave the answer in this form, but it should be x component, y component, and z component. So negative 1.615 I, 5.247 J, 2.442 K meters per second. The meaning of negative 1.615 is this is the x component of velocity, the y component of velocity in meters per second, the z component of velocity in meters per second. Level 4, find the angles between the force F and the x, y, and z axis. So let's compute the magnitude so that we can have the unit vector of F. Remember, the unit vector have cosine theta x I. So that's cosine theta x, so we can easily compute for the angles. So let's compute for the magnitude first of F, square root of 1,200 square plus 800 square plus 1,500 square. So the magnitude of F is 2081 newtons. Then lambda of F is vector F over its magnitude. So 1,200I plus 800J minus 1,500K over 2081. Then decimal form, 0.5766i plus 0.3844j minus 0.7208k. This is cosine theta x. So therefore, theta x is inverse cosine of 0.5766. So we can now compute theta x, 54.79 degrees. In theta y, inverse cosine of 0.3844. So theta y is 67.39 degrees. Theta z, inverse cosine of negative 0.7208. Remember, if the direction cosine is negative, the angle is more than 90 degrees. So 136.1 degrees. Level 5 problem. The cable exerts a tension of 2 kilonewtons on the fixed bracket at A. Write the vector expression for the tension T. So here is the figure. So tension T in vector form is, because that's a vector, is magnitude times quantity xb minus xai, yb minus yaj, quantity g sub b minus g sub a, k, all over square root of whatever the difference, you just squared it, distance AB. So T is, in vector form, is magnitude of the lambda of AB, where magnitude is 2. So that's it. So it is equal to 2, 0, G sub B is, X sub B is 0, then minus 1.2i. Then along Y, is the Y, that's 0.5, because A is on the XZ plane, so 0. Then 0.4 above the y-axis, above the xy plane. B is 0.4 above the xy plane. Ya is only 0.3 above the xy plane, so 0.4 minus 0.3 k. Then distance, square root of, you just square this delta x, delta y, and delta z. So tension is 2 times negative 1.2i plus 0.5j plus 0.1k over this distance is 1.304. So there are two ways to express T in x, y, and z components of the tension. So that's the first answer. The other way is magnitude of tension, then just the unit vectors of distance. So you may also write it into this way. So either of these two is correct, but it depends on the condition in the problem. Level 6 problem. Express the 5 kilonewton force F as a vector in terms of the unit vectors I, J, and K. Determine the projection of F onto the x-axis. So this is just Fx. And onto the line OA. So we have to obtain the dot product. This is the component of F in the direction of OA. So obtain the dot product of F and the unit vector of OA. So here is the given figure. So first, theta z can be computed. 90 minus 35. This is a vertical angle. So theta z is 90 minus 35, so 55 degrees. So cosine of theta z therefore is cosine of 55. So it is in decimal form 0.5736. Then to solve for theta x, we need fx. We compute this component first. This is a right triangle, vertical, horizontal. This is supposedly fxy. By our experience, this is 5 cosine of 35. Then since fx is adjacent to 60 degrees, so fx therefore is 5 cosine 35, this value here, and it is positive in the positive x-axis, times cosine of 60. So fx is 5 cosine 35 times cosine of 60, because it is adjacent to 60 and it is positive. So 2.048 kilonewtons. Remember that fx is f cosine theta x. So 2.048 equals 5 cosine of theta x, the angle that f makes with the positive x-axis. So from here, we can compute cosine theta x, which is 2.048 over 5. So cosine theta x is 0.4096. Likewise, for Fy, this component here, which is equal to this opposite to 60. So remember, this is F cosine of 35, this hypotenuse of this diagonal of the rectangle here, then times sine of 60. So that is Fy. That's also positive. So Fy is 5 cosine 35, then times sine of 60, which is equal to this, and that is Fy. So Fy is 5 cosine 35 degrees sine 60 degrees equals F, which is 5 cosine of theta y. So cosine theta y can now be computed. Cosine 35 sine 60 is 0.7094. Then everything is already present. We can now write F in vector form as F equals 5 quantity cosine theta xi plus cosine theta yj plus cosine theta zk. So F is 5 quantity. These are the direction cosines. 0.5, 0.4096, 0.7094, then 0.5736. And we can also expand if you want. 5 times 0.496, so these are the result, and so on. So that the projection of F onto the x-axis is Fx. So Fx is 2.048 kilonewtons. Now how about the component or projection of F onto the line OA? So we write OA in the unit vector of OA simply, it has only x and y component, it has no z component. It is on the xy plane. So it is cosine of 30. It forms an angle of 30 degrees. So this is cosine of 30 degrees I, then sine of 30j for lambda of OA. So FOA is the dot product of vector F and the unit vector of OA. So if you expand that, that's F, magnitude of lambda of OA, which is 1, cosine of the angle between F and OA. So therefore, if you interpret F cosine of theta FOA, that's the component of F in this direction. So you may also look at that product in the discussion. So FOA is vector F, this one. Then lambda of OA is quantity cosine of 30i plus sine of 30j. Remember that product, we just obtained the product of corresponding components. So 2.048 cosine 30 plus 3.547 times sine 30. I dot j is 0. Remember, j dot I is also 0. Then k here has no partner, so that's why it will be 0. So FOA is equal to 2.048 times cosine 30 plus 3.547 times sine 30. So FOA is equal to 3.547. Level 7. In checking a recently installed fence post for adequacy of the ground support, a person exerts a force P negative 160I plus 40J plus 60K newtons on top of the post as shown. Determine the angles which P makes with the positive x-axis, that's theta x, and with the xz plane. So here is the given figure. Then the xz plane is this horizontal plane. So this diagonal here of this rectangle. And the magnitude of that pxz is square root of px square plus pz square. While the magnitude of P is square root of 160 square plus 40 square plus 60 square. So therefore, cosine theta x is P sub x negative 160 divided by P. And P is square root of 160 square plus 40 square plus 60 square. So cosine theta x is negative 160 px over square root of magnitude of p, 160 square plus 40 square plus 60 square. So let's solve it very shortly. So theta x is 155.7 degrees, while the angle that P makes with the XZ plane, which is this vertical angle here, is component of PXZ or magnitude of PXZ, which is square root of PX square, negative 160 square plus 60 square, divided by P, which is this one. There's no need to compute for P. So that's theta XZ. So cosine of theta XZ is PXZ over P. And PXZ is square root of PX square. So negative 160 square plus PZ square, which is 60 square, over P. You just copy this. Square root of 160 square plus 40 square plus 60 square. So using your calculator, theta XZ is 13.17 degrees. Level 8 problem. The unstretched length of the spring is B. Determine the force which the spring exerts on point B of the space frame if B is, the value of small letter b is 0.3 meter. So here is the given figure. Remember that we have to determine the force which the spring exerts on B. So it is directed in that direction. So tension is in that direction from B to A. So to reach point B, you have to move leftward along Y. So delta Y is negative by B. Then back downward along Z. So both Y and Z will be negative. Only X is positive forward. So the unstretched length is equal to 0.3. And the force in the spring is spring constant times change in displacement, which is final displacement minus initial displacement. So K times final displacement minus initial displacement. Remember, displacement is different from length. The final displacement would be final length of spring minus initial length of spring. That's the meaning of that. That's the displacement. So the length of AB initially is B is 0.3. Therefore, initial displacement is 0 because it is unstretched at that condition. When B is 0.3, the spring is unstretched. The final length of AB is square root of 1.5 square. Length of AB final, square root of 1.5 B square plus B square along Y, then plus B square along Z. So LAB final is square root of 17 over 2 of B. Since B is 0.3, final length of AB is square root of 17 over 2 times 0.3 in decimal, that's 0.6185 meter. If this is the final length of AB, then the final displacement is final length minus initial length, which is 0.3. So 0.6185 minus 0.3, that's the final displacement, 0.3185. So the force in the spring, therefore, or the tension in the spring is spring constant, which is 400 Newton per meter times 0.3185. And it is equal to 127.4 newtons. Then in vector form, it is 127.4 times 1.5 times 0.3i, then minus 0.3j, minus, because to the left along y, so negative 0.3, downward along z, negative 0.3k, forward along x, 1.5 times 0.3i. So it is magnitude of force, then 1.5 times 0.3i minus 0.3j minus 0.3k over length of AB, or distance AB, which is 0.6185 final. So in component form, 90.73i minus 61.79j minus 61.79k. So that's it, newtons. Level 9 problem. The force F has a magnitude of 2000 newtons and is directed from A to B. Calculate the projection F sub CD of F onto line CD and determine the angle theta between F and CD. So it is the dot product of F with the unit vector CD. So here is the given figure so that we won't be confused in expressing F in vector form. Let's have our X, Y, Z. So let us say that's the orientation. So from A to B, the movement would be to the left along X, negative 0.2i, up 0.2 along Y, then backward along Z by 0.4. So therefore, F is magnitude 2000 times quantity negative 0.2i, positive 0.2j, negative 0.4k divided by distance square root of 0.2 square plus 0.2 square plus 0.4 square. Then F in component form, negative 816.5i plus 816.5j minus 1633k newtons. Then the unit vector CD, this is going down along Y, so negative 0.2j, then backward along Z, negative 0.4k. So FCD is F dot lambda of CD. Then it is also F cosine theta CD if we expand. That's why it is the component of F in the direction of CD, where theta CD is the angle between F and CD. So lambda of CD is again negative 0.2j, negative 0.4k divided by distance square root of 0 square, there's no I, 0.2 square plus 0.4 square. You just square these components or coefficients. So in decimal, lambda CD is negative 0.4472j minus 0.8944k. Then obtain the dot product. FCD is equal to F in vector form dot with lambda of CD. And remember that we can only multiply corresponding vectors. So 816.5 times negative 0.4472, then plus negative 1633 times negative 0.8944. So the projection of FCD onto F can now be computed 1095 newtons. Then this is equated to F cosine theta CD, where F is 2000. And we can compute theta CD. So 1095 equals 2000 cosine of theta CD. So theta CD is equal to 56.8 degrees. Level 10 problem. The cable BC carries a tension of 750 newtons. Write this tension as a force T in vector form acting on point B in terms of the unit vectors I, J, and K. The elbow at A forms a right triangle. So meaning OA, and in this direction, that's 90 degrees. So B is below the XZ plane, and therefore XB is still 1.6 because this is a right angle. So XB is 1.6 meter. YA is below the XZ plane by this amount. It is 0.8 sine 30, so negative 0.8 sine of 30 degrees from this horizontal plane, XZ plane. The hypotenuse is 0.8 and this is angle, so negative 0.4. While G sub B, this is the G sub B, it is also forward 0.8 cosine of 30 G sub B, this distance here. While this is YB, negative. So 0.6928. So we need to evaluate x sub c minus x sub b. X sub c is 0 because it is on the yz plane. So 0 minus 1.6 x sub c minus x sub b. Terminal minus initial. So negative 1.6. Y sub c minus y sub b is 0.7 minus negative 0.4. YB is negative 0.4, so 1.1. Then G sub C is 1.2, positive minus 0.6928 G sub B. So it is 0.5072. So I hope you can also visualize in this 3D quickly, because if you cannot think of it quickly, then it will take time for you to solve. The time allotted for this problem might be running out, so you cannot answer this on time. So therefore, T is magnitude times quantity negative 1.6i plus 1.1j plus 0.5072k divided by square root of, you just square all these values because that represents the distance of BC. So using your calculator, that's the tension, 598.0i plus 411.1j plus 189.6k. Level 11, the tension in the supporting cable BC is 800 pounds. Write the force which this cable exerts on the boom OAB as a vector T. Determine the angles theta x, theta y, and theta z which the line of action of T forms with a positive x, y, and z axis. So here is the figure. So x sub c, because tension is from B to C, x sub c minus xb is 6, because this is the x-axis, 6 minus 5, so 1. Y sub c, 0, because c is on the xz plane, minus y sub b, 7, so negative 7. 6 minus 5, 1. 0 minus 7, negative 7. Then g sub c minus g sub b is 3 minus 1.5, so 1.5. So therefore, tension is 800, quantity I, minus 7j plus 1.5k over square root of 1 square plus 7 square plus 1.5 square. Again, 1i is 6 minus 5. Negative 7 is 0 minus 7. And 1.5 is 3 minus 1.5. That's 1.5. So tension is 110.7i minus 774.7j plus 166.0k. Theta x is inverse cosine of x component of tension divided by magnitude of tension 800. So inverse cosine of 110.7 over 800. So theta x is 82.05 degrees. Theta y is negative 774.7 over 800. Inverse cosine. So theta y is 165.6 degrees. Then theta z is inverse cosine of 166 over 800. So 78.02 degrees. We have theta y, which is large because the component is negative. This is the y-axis. So the angle between tension and the positive y-axis is large. 165.6. That angle there. Level 12, determine the angle theta between the 200-pound force and line OC. So this is the cosine theta is component of the 200 pound on OC divided by 200, where component of the 200 pound on OC is obtained by dotting the force F with the unit vector of OC. So F in vector form is 200, then it is backward along X, negative 12I, forward along Y, 24J, upward along Z, 8K, then divided by distance. So cosine theta is magnitude or component of the force along OC divided by F, which is 200. So FOC is F dot lambda of OC, where F is 200, negative 12I, positive 24J, positive 8K over square root of, you square this, 12 square plus 24 plus 8 square. So in decimal, F is negative 85.71I plus 171.4J plus 57.14K pounds. Then the unit vector of OC is just 12I from O along X, 12I, then along Y, 24J, divided by distance, square root of 12 square plus 24 square. So 12I plus 24J over square root of 12 square plus 24 square. In decimal, the unit vector OC is 0.4472I plus 0.8944J. Then obtain the dot product. FOC is quantity negative 85.71I plus 171.4J plus 57.14K dot quantity 0.4472I plus 0.8944J. So FOC is negative 85.71 times 0.4472 plus 171.4 times 0.8944. So FOC is equal to 114.97 pounds. Finally, cosine 114.97 equals F200 cosine of theta. So theta can now be computed. Inverse cosine 114.97 over 200 is 54.91 degrees. Level 13. The access door is held in the 30-degree open position by chain AB. If the tension in the chain is 100 newtons, determine the projection of the tension force onto the diagonal axis CD of the door. So here is the figure. This is vertical wall. This is horizontal floor. So this distance is 900 cosine 30. 900, this is 900 mm cosine 30 is 779.4. Then 900 sine 30, this vertical distance is 450 mm. So the direction AB is going to the left. Remember, this is the x-axis, vertical is y-axis, the z-axis. Or you can orient it as long as it is consistent by your own. So let's maintain x, y, then z. So from A to B, we move to the left along x, negative 779.4 I. Then, because this is 450, that's 900, we move up along y by 450 only, 900 minus 450. So positive 450 J. Then backward along z, negative 1200K. Then divided by square root of distance, you just square. So tension is 100, quantity negative 779.4 I, 450 J, then negative 1200K, then square root of, you just square these components. So again, going to the left, negative 779.4, up by 450. 450 is 900 minus 450. Then backward along Z by 1200, so the outside negative 1200K. Then distance, you just square that. So T is negative 51.96 I plus 30J minus 80K newtons. Because we're going to obtain the dot product of T with the unit vector of CD to obtain its component on CD. So CD is from C to D. What we do is we move rightward along x 779.4i, upward along y 450, so positive 450j, then backward along z negative 1200k, then divided by the square of distance. So lambda CD is 779.4i plus 450j minus 1200k, then square root of the squares of these components. So unit vector of CD is 0.5196i plus 0.3j minus 0.8k. So the component of the force along diagonal CD is obtained by dotting this tension force in vector form with that lambda CD. So TCD is quantity negative 51.96i plus 30j minus 80k dot with quantity 0.596i plus 0.3j minus 0.8k. So it is negative 51.96 times 0.5196 plus 30 times 0.3 plus negative 80 times negative 0.8. So using your calculator there, 46 newtons. Level 14, find the resultant of the two forces, each of which is of magnitude P. So here's the given figure. So there are only two forces. Let's express the first force in vector form so that we can obtain the resultant easily. So POA. To reach A, beginning with O, we move along X A, along Y positive A, along Z A also. So POA in vector form is equal to P magnitude quantity AI plus AJ plus AK over square root of A square plus A square plus A square. Therefore, POA is P quantity I plus J plus K over square root of 3. POB on the other hand is along XA, along Y positive. So forward along X, forward along Y. So positive. So it is P quantity I plus AI plus AJ over square root of A square plus 0 square. There's no K. So POB is P quantity I plus J over square root of 2. Therefore, R is POA plus POB. So we add corresponding components. So R is 1 over square root of P times 1 over square root of 3 plus 1 over square root of 2i plus 1 over square root of 3 plus 1 over square root of 2j plus 1 over square root of 3k only. Only OA has k component, P 1 over square root of 3. So expressing in decimal, R is P times quantity 1.284i plus 1.284j plus 0.5774k, or 1.284pi plus 1.284pj plus 0.577pk. That's the other way. Level 15. Determine the resultant of the two forces shown. So here is the given figure. Let's call 120 pound as F1, 100 as F2. For 120 pound, it is negative along X to reach this point, negative 4i, positive 3j. So 120 quantity negative 4i plus 3j over square root of 4 square plus 3 square. So that's F1. 120 times quantity negative 4i plus 3j over square root of 4 square plus 3 square. So F1 is negative 96i plus 72j. Call this F2, this 100 here. So movement to reach this point is positive 3j along y, negative 5k along z. That's the movement. So it is 100 quantity 3j minus 5k divided by square root of 3 square plus 5 square. So F2 is in decimal 51.45j minus 85.75k pounds. Therefore, the resultant, which is F1 plus F2, is negative 96i plus quantity 72 plus 51.45j, then plus negative 85.75k. So combining this, R is negative 96I plus 123.4J minus 85.75K. So that's the resultant. Level 16, the magnitudes of the three forces are F1, 1.6 kilonewtons, F2, 1.2 kilonewtons, and F3, 1.0 kilonewtons. Compute the resultant in the form R in terms of the components, Rxi plus Ryj plus Rzk, and R as magnitude of R, then unit vector, the resulting unit vector. So here is the given figure. Since F1 is directed towards the positive x-axis, in vector form, F1 is 1.6i. F2 is positive x, then positive y. It is along x in this direction, along y in that direction. This is 35 degrees. This is along x. So F2 is 1.2. This is sine of 35i, 1.2 sine 35i, then 1.2 cosine of 35 degrees j. So that is F2. F2 is 1.2 sine of 35. This is Fx of F2. Then this is Fy of F2, y component of F2, 1.2 cosine of 35j. In decimal, F2 is 0.6883i plus 0.9830j kilonewtons. F3 is on the y, positive, and z. So this is magnitude of F3, 1 cosine of 65 along y, j, then 1 sine of 65, k. So F3 is 1.0 cosine 65 j plus 1 sine of 65 k. In decimal, F3 is 0.422 j plus 0.9063 k. So the resultant is the sum of F1, F2, and F3, and we add corresponding components. So R is equal to 1.6 plus 0.6883i plus 0.9830 plus 0.4226j. Then there's only 1k, 0.9063k. So combining, R is 2.288i plus 1.406j plus 0.9063k. So that's letter A. Letter B, let's find for the magnitude of R by getting the sum of the squares of these components. Square root of 2.288 square plus 1.406 square plus 0.9063 square. So the magnitude of the resultant is 2.834 kilonewtons. Then R is, if we factor this out, then the unit vectors lambda components would be 2.288 over 2.834. So R is 2.834 quantity 0.8073i plus 0.4961j plus 0.3198k. This is obtained by dividing 2.288 by 2.834. 1.406 divided by 2.834 is that value. 0.9063 divided by 2.834 is that value. So in this form, R is 2.834 quantity 0.8273i plus 0.4961j plus 0.3198k. That's it for that problem. Level 17, a baseball is thrown with spin so that three concurrent forces act on it as shown in the figure. The weight W is 5 ounces, the drag T is 1.7 ounces, and the lift L is perpendicular to the velocity V of the ball. If it is known that the Y component of the resultant is negative 5.5 ounces and the Z component is negative 0.866 ounces, determine L, theta, and R. So this is the given figure. So let's express all these vectors in vector form. So the drag force with magnitude of 1.7 ounce, it is in the negative x direction, so negative 1.7i. The weight is in the opposite y direction, so it is negative 5j ounces. Then the lift is along y, this one. This is L sine theta, but negative. along Z L cosine theta, but negative also. So the lift in vector form is negative L sine theta J, negative L cosine theta K. Negative L sine theta J, negative L cosine theta K on this. Then we are given the information that the y component of the resultant is negative 5.5. So let's form the resultant first. The resultant therefore is negative 1.7i, then negative 5, negative L sine theta j, then negative L cosine theta k. So only the j component have two values, negative 5 and negative L sine theta j. So this is Rx, this is Ry, and this is Rz. So Ry is negative 5.5, so we equate it to negative 5 minus L sine theta. Simplifying L sine theta is 0.5. Call that equation 1. Then Rz is negative 0.866, and it is equated to negative L cosine theta. So L cosine theta is 0.866. So dividing equation 1 by equation 2, L sine theta over L cosine theta, cancel L, so tangent theta is 0.5 over 0.866. So inverse tangent of 0.5 over 0.866, theta is 30 degrees. Substitute in equation 1 to solve for L. L sine 30 degrees equals 0.5. So the lift force is 1 ohms. Then finally, the resultant is square root of Rx square, where Rx is 1.7 square, Ry is 5.5, and Rz is 0.866 square. So the resultant, the magnitude of the resultant is 5.822 ounces. So this is our magnitudes only, light, not boldface. Level 18. The vertical post is secured by 3 cables. The cables are pretensioned so that the resultant of the cable forces F, Q, and P is directed along the z-axis. If F is 120 pounds, find P, Q, and R. So here is the given figure. Let's express F in vector form. The magnitude is 120. So F is 120. It is going down along Z, going left along Y. So it is 120 negative 8J negative 12K over square root of 8 square plus 12 square. So 120 negative 8J negative 12K over square root of 8 square plus 12 square. In decimal, F is negative 66.56 J, negative 99.85 K pounds. Next, Q, from A to C, going down along Z, so negative 12K. Along X, backward, so negative 6I. Along Y, forward, so 6J. Negative 6I. So magnitude of Q, negative 6I, positive 6J, negative 12K over distance. So Q is magnitude of Q, negative 6I, positive 6J, negative 12K over square root of 6 square plus 6 square plus 12 square. In decimal, Q is negative 0.4082 QI plus 0.4082 QJ minus 0.8165 QK. Then P is going 6 positively, 8 positively along Y, then 12 negatively along Z. So 6I, 8J, negative 12K. So P is equal to magnitude of P, Quantity 6i plus 8j minus 12k over square root of 6 square plus 8 square plus 12 square. Then in decimal, p is 0.3841 pi plus 0.5121 pj minus 0.7682 pk. Since the resultant is directed along the z-axis, obviously downward, it means Rx is 0, Ry is 0, and Rz is equal to R. So Rx is 0 and this is equal to, there's no I here, negative 0.4082 Q and plus 0.3841 P equals 0. So call that equation 1, 0.3841 P minus 0.4082 Q equals 0, equation 1. Ry is also 0 and it is equal to negative 66.56 plus 0.4082 Q plus 0.5121 P. So simplifying, 0.5121 P plus 0.4082 Q equals 66.56. So solving equations 1 and 2 simultaneously, we can now compute P and Q. So P is 74.27 pounds, Q is equal to 69.88 pounds, and the resultant, which is Rz, because Rx is 0, Ry is 0, so Rz is negative 99.85, negative 0.8165 of Q, which is 69.88, and negative 0.7682 of P, which is 74.27. So R sub Z is equal to negative 214.0 pounds. So the magnitude of R is 214 pounds, because that's the magnitude only. Level 19, find the magnitude and direction of the resultant of the two forces shown, knowing that P is 400 newtons and Q is 300 newtons. So here is the given figure, and I hope you can now analyze the X component, Y component without further drawing the details. So for Px, this is the component, negative, so we compute this first. This is P 400 cosine 30. Then Px is opposite to 15, so times sine of 15. So Px is negative. So Px is negative 400 cosine of 30, this value here, then times sine 15. So negative 89.66 newtons. Py is upward, so it's just 400 sine of 30 or 400 cosine of 60, because theta y of P is 60. So it's the same, 200 newtons. Then Pg is directed along this axis here. This is 400 cosine 30, then adjacent to 15 times cosine of 15 further. So Pg is 400 cosine of 30, then times cosine of 15, this component here. So 334.6. Qx, on the other hand, is we first compute this adjacent side of this right triangle. This is Q, 300 cosine of 50. Then x is adjacent of 20, so 300 cosine of 50, then times cosine of 20. That's Q sub x. 300 cosine 50, then times cosine of 20, because this is the x-axis. So 181.2 newtons. Qy is upward. It is just Q 300 sine of 50 or 300 cosine of 40. So Qy is 300 sine of 50 or 300 cosine of 40, 229.8. And finally, Qz is in that direction, opposite to 20, so negative 300 cosine of 50, this value here, then times sine of 20. Negative 300 cosine of 50 degrees, sine of 20. If you want the details, you look at example 2, I think. You draw the top view so that you can analyze. So negative 65.95. Therefore, Rx is negative 89.66 plus 181.2 91.54 newtons. Ry is 200 plus 229.8, 429.8. Then Rz is 334.6 plus negative 65.95, 268.65 newtons. So the magnitude of the resultant, because we are looking for the magnitude and direction of the resultant, so the magnitude is square root of 91.54 square plus 429.8 square plus 268.65 square. So the magnitude of R is 550 newtons. Then for the direction, cosine theta x is 91.54 over 515, inverse cosine. Inverse cosine of 91.54 over 515. So theta x is 79.76 degrees. Theta y is inverse cosine of 429.8 over 515. So theta y is 33.43 degrees. Then theta z is inverse cosine of 268.65 over 515. So theta z is 58.56 degrees. Level 20, this is the last example. The end of the coaxial cable AE is attached to the pole AB, which is strengthened by the guy wires AC and AD. Knowing that the tension in AC is 750 newtons and that the resultant of the forces exerted at A by wires AC and AD must be contained in the XY plane, determine the tension in AD, the magnitude and direction of the resultant of the two forces. So take note of this statement that the resultant of the forces exerted at A by wires AC and AD must be contained in the XY plane. Meaning say the resultant must be in the XY plane. There's no Z component. So meaning RZ is 0. So let's express tension in AC in vector form. We can compute the components because the tension in AC is given. So it is for the X component, because tension is from A to C, so we compute this component first. So it is T 750 cosine of 60. Then this is the X component, so times adjacent to 20, so times cosine of 20. It is positive 750 cosine of 60, this value here along BC, then times cosine of 20, positive towards the x-axis. Tension is from A to C. So TACX is 750 cosine 60 times cosine of 20. So 352.4 newtons. TACY is simply negative going down. So negative 750 sine of 60, opposite to 60. So negative 750 sine of 60. So it is negative 649.5. Then TAZZ, this is the positive z-axis, so it is in that direction. So it is, because tension along BC is 750 cosine 60, and this component is opposite to 20, so negative 750 cosine 60 times sine of 20. TACZ, negative 750 cosine of 60 degrees times sine of 20. This is 750 cosine 60, then this is TACZ, opposite to 20, so times sine of 20. Just make it negative. Then tension AD, X. So we compute this first. This is tension AD sine of 36 because it is opposite. And ACX is this value here in the positive direction, opposite to 48. So we multiply further by sine of 48. So TADX is tension in AD, magnitude sine of 36, then sine of 48. That's the tension in ADX. Tension in AD sine 36, which is this projection along BD, then times sine of 48, this one. So 0.4368 tension in AD. TADY is simply tension in AD cosine of 36 negative going down. TADY, negative tension AD cosine of 36. In decimal, negative 0.8090 tension in AD. Then tension in AD along Z, after this projection, tension AD sine 36, it is adjacent to 48, so times cosine of 48. So it is positive tension in AD sine 36, which is this projection along BD, then times adjacent to 48 cosine of 48, this value. So if you still find it difficult, it's because your trigonometry background is poor. But if you can follow, you're good in trigonometry. So take note that the resultant must be contained in the xy plane. RZ is 0. So we sum up forces along Z0, negative 128.3 plus 0.3933 tension in AD equals 0. So we can now compute tension in AD. Tension in AD is 326.2 newtons. Then the magnitude and direction of the resultant of the two forces. There is only Rx and Ry. So Rx is 352.4 plus 0.4368 of tension AD, which is 326.2. So 494.9. Ry is negative 649.5 plus negative 0.8090 of 326.2 tension AD. Negative 913.4. Of course, Rz is 0, known. So the magnitude of R is square root of 494.9 square plus 913.4 square plus 0 square. So R is 1039 newtons. Therefore, for the direction, theta x is inverse cosine of Rx over R. So inverse cosine of 494.9 over 1039. It is equal to 61.55 degrees. Theta y is inverse cosine of negative 913.4 over 1039. So theta y is 151.5. Finally, theta z is inverse cosine of 0 over 1039, so 90 degrees. So that's it for all these problems. I hope that you were able to follow all the solutions, discussions, explanations, so levels 1 to 20. If not, you just go over with the explanations, or you proceed to statics for beginners 2. The principles are there. Or you review trigonometry if you find the trigo difficult in this problem.